last time we'd left off, we'd been discussing topics related to an overview of streams. I talked about some of the common aggregate operations like map and filter and collect and so on. We talked about some of the benefits of streams. We did a little stream visualization. We also talked a bit about how streams compare and contrast to other technologies, such as System 5 streams or the pipes and filters pattern or pipelines in the Unix command shell, and so on and so forth. What we're going to do now is we're going to start talking about various stream features in a lot more detail. But in order to do that, we're first going to describe a case study program that we'll use for a number of lessons in order to make the points more tangible. So rather than just talking abstractly about streams, we're going to show the various features in the context of this case study program. And the program is called the SimpleSearchStream program. And we'll use this program to showcase a bunch of Java sequential stream capabilities. And you can find all the source code that we're going to cover here in this program called SimpleSearchStream. So let's first start out by just kind of giving you the big picture view of what this program does. What this program does is it finds words in an input string. So there's a lot of different ways of doing this, and our point here is just to be able to find where words occur in the string, if they occur at all. The input string we're going to use for this particular example, without loss of generality, contains the lyrics to the famous Do Re Mi song from the classic movie The Sound of Music. And if you've never seen the movie, it's probably worth watching. I've actually been on the Sound of Music tour in Salzburg, Austria, and it's really fun. And it's a very catchy song. You may have heard it before when you were a kid. And basically, it's giving names to the musical notes: do, re, mi, fa, sol, la, ti, do. And so what we're going to do is we're going to take the lyrics of the song, and then we're going to go search for all the places where the words do, re, mi, fa, sol, la, ti, do appear in the lyrics. And we'll use this to showcase a whole slew of Java functional programming features like lambda expressions and method references, as well as, of course, the Java sequential streams, aggregate operations, and constructs, and so on. The program will print output in a nicely formatted order. Here's kind of a rendition of what this looks like. And as you can see here, for every word we search for, it will tell us what index location that word appears in the lyrics to the song. So in the input string, the word re matches at a whole bunch of places. The word ti matches at a whole bunch of places. The word la matches at a whole bunch of places, and so on and so forth for each of the different words. We also have another cool feature where you can ask it to print slices of the results. So let's assume that you've got all the results for do, re, mi, fa, sol, la, ti, do, but you just want to print from la to the end. So what you can do here is say print a slice starting at la, and it'll print where la appears in the indices and where ti appears in the indices. And that's what we would call a suffix slice. There's also a prefix slice where you can say print everything from the beginning up to, but not including, a particular word. And we'll talk more about how all this stuff works as we get further into the discussion. Let me give you a quick overview of what the code actually looks like. If you take a look at the source code for the program, there's a driver program that's available here in this link. If you get the slides and you click at the bottom of the PDF, it'll take you to the repository where the code exists. And this is just the main driver program. This driver program doesn't do anything particularly functional. It just makes some objects and introduces and initializes various things. So for example, the first thing we do is we go out and we take the name of an input file, and we go ahead and read in the contents of the file, which will be the lyrics to the Do Re Mi song, and that will then store the input into a string. So we have a string called input, which contains the contents of the file. Likewise, we also have a file that contains the list of words to find, the Do Re Mi parts, and once again, we go ahead and input that and store it in a list of strings, one string for every word we're going to look for. The next thing we do is we go ahead and create an object called a word searcher. And as the name implies, the word searcher is going to take the input string and create an object that can be used to search for the words to find in the input string. And then down here, we can take that searcher object of type word searcher and say, please go and find the places where the words defined match in the input string. And what we get back is a list of something called search results. And the search results keep track of where each of the words appears, where the indices are for the different words in the song. And then the final things we do is we go ahead and we print the results. And there's a couple different print calls. I just show one of them here. And print results are going to print the results out in a nicely formatted way so you can see where they occur. So that's basically the overall structure of the program. Of course, we will later come along and talk in a lot more detail about how all these things work. So that's the end of the overview of the SimpleSearchStream program. And now we're going to talk in more detail about other aspects of this that make it interesting.